Hello everyone, and welcome to another episode of ChemTech, the show where we talk about technology in chemistry class. I'm reporter Ethan, and on today's show we'll be learning the answers to questions like, what is nanotechnology? How can it be used for energy applications? And what are some potential risks? Nanotechnology is defined by the Oxford Dictionary as the branch of technology that deals with dimensions and tolerances of less than 100 nanometers, especially the manipulation of individual atoms and molecules. Well, what is a nanometer? It is the length of 1/1000th of a meter. To put that into perspective, if the diameter of this table tennis ball represented 1 nanometer, 1 meter would be the circumference of the entire Earth. Nanotechnology is a relatively new field in science, and this is largely due to the fact that microscopes have only recently been able to view objects at a nanoscale. Because of this, nanotechnology is being used for a vast number of industries, including materials, electronics, medicine, and energy. Today we will be focusing on the energy applications of nanotechnology, how it can improve fuel efficiency, and how it can be used to create nanostructured solar cells. Fuels are a widely utilized energy source. They're used to power cars, planes, and ships. However, fuels are finite and produce emissions. An American company, H2 Oil, has used nanotechnology to pioneer a fuel additive which improves fuel efficiency, saves costs, reduces emissions, and increases engine power. To achieve this, H2 Oil uses liquid nanotechnology where the fuel additive forms a stable lattice structure within the fuel. This lattice structure consists of nanoclusters 3 to 9 nanometers in diameter. These are evenly distributed within the fuel. These nanoclusters inside fuel droplets produce steam when exploding at high temperatures. These microexplosions assist in breaking up large fuel droplets and creating a better air-to-fuel ratio. This improves the efficiency of the combustion reaction. The combustion reaction that happens inside a piston engine can be written as the hydrocarbon or fuel burns in oxygen to create the products carbon dioxide and water. Having this technology integrated with fuel has proven to significantly reduce emissions and save costs. So far, H2 Oil have used this fuel additive in cars, oil tankers, trucks, and trains. The use of nanotechnology has prevented large amounts of harmful emissions being released into the atmosphere. What's better than increasing fuel efficiency? Not using fossil fuels at all. We're now going to talk to a solar panel expert to explain how conventional solar panels work. Hello and welcome to the show. Thanks, I'm happy to be here. So tell me about how do solar panels convert sunlight into energy? The photovoltaic cells inside solar panels are what actually convert light into electricity. These are made of 2 layers of a semiconductor sandwiched together. The top layer is referred to as the N-type semiconductor because it is negative and has more electrons. The bottom layer is referred to as the P-type semiconductor because it is positively charged and has fewer electrons. When photons hit this material, more electrons from the P-type material transfer to the upper N-type material. Electrons then flow from the N-type semiconductor to the P-type semiconductor through a wire to form the electric current. Interesting. How is nanotechnology being implemented into this? Companies like QD Solar are using technologies with similar principles but with perovskites and colloidal quantum dots. Put simply, perovskites are organic-inorganic hybrid compounds that can also act as semiconductors. Unlike silicon, perovskites are easy to manufacture and can be tuned for certain wavelengths of light. Perovskites are particularly effective at converting ultraviolet and visible light into electricity. Colloidal quantum dots are nano-sized semiconductor particles. They can also be tuned to certain wavelengths to harness near-infrared radiation. Solar nanotechnologies are continuing to advance and have proven to be a viable energy alternative. Wow, thanks for your time. Hope to see you again. The pleasure's all mine. H2 Oil and QD Solar are just 2 of the many companies pioneering the use of nanotechnology for energy applications. Increased use of nanotechnology in the future is very likely, and there are many overall benefits to the community. However, like most breakthroughs, there are risks. Safety precautions must be made considering regulations for manufacturing and the effects of nanomaterials on the body. Because nanotechnology is so new, many techniques and processes are experimental, which may lead to harm. Further testing needs to be conducted regarding this. Renewable energy sources are vital for the reduction of air pollution and reducing the effects of climate change. Through fuel additives, solar power, and much more, nanotechnology is helping Earth become cleaner and more sustainable. This is ChemTech. Have a good day.